Dear viewers, if you are a student learning this subject for the very first time, whatever the topic is, make sure that you work along with me so that you can understand each and every step easily and you can solve it and you can memorize it also. Hello viewers, today we'll learn about response of second order system for critically damped case and unit step input. As we all know, the standard form of closed loop transfer function for second order system is C of S by R of S equal to omega n square by S square plus 2 zeta omega n S plus omega n square. And for critically damping case, the damping ratio is 1. So, therefore C of S by R of S equal to omega n square by S square. Here zeta is 1. So, 2 omega n S plus omega n square. That is omega n square by S plus omega n whole square. Now, talking about unit step, R of t equal to 1, that is nothing but R of S equal to 1 by S. The response in S domain, C of S is equal to R of S into omega n square by S plus omega n square, where R of S is 1 by S, so 1 by S into omega n square by S plus omega n square. Now for this, by partial fraction expansion, we can write C of S equal to omega n square by S into S plus omega n whole square equal to A by S plus B by S plus omega n whole square plus C by S plus omega n. Now, we are supposed to find out the coefficient. For coefficient A, C of S multiplied by S for S equal to 0. Omega n square by S into S plus omega n whole square into S for S equal to 0. S is 0. So you are left with omega n square by omega n square, that's equal to 1. So the coefficient value of A is 1. Now we'll find coefficient B. B equal to C of S into S plus omega n whole square for S equal to minus omega n. And C of S is omega n square by S into S plus omega n whole square into S plus omega n whole square for S equal to minus omega n. With omega n square, S is minus omega n. It is minus omega n. So coefficient B is minus omega n. Now we'll find out coefficient C, that is nothing but first derivative, that is d by ds of C of S into S plus omega n whole square for S equal to minus omega n. That is nothing but d by ds of omega n square by S into S plus omega n whole square into S plus omega n whole square for S equal to minus omega n. This got cancelled, and this is d by ds of omega n square by S for S equal to minus omega n. D by ds of 1 by S is nothing but minus 1 by S square into omega n square for S equal to minus omega n. That would be minus omega n square by is nothing but minus omega n. So S square would be minus omega n whole square. So that would be got cancelled, and you are left with minus 1. The coefficient C is nothing but minus 1. Now C of S, after replacing with coefficients, we get A is 1, so it is 1 by S. B is minus omega n, so obviously it is omega n by S plus omega n whole square. And C is minus 1, S plus omega n. This is an S domain. We are supposed to find out the response in time domain. So C of t equal to Laplace inverse of C of S equal to Laplace inverse of 1 by S minus omega n S plus omega n whole square minus 1 by S plus omega n. This would be, for Laplace inverse of 1 by S is 1, and for this one omega n into t e power minus omega n into t. And for this one Laplace inverse, that is e power minus omega n into t. We can still write this as 1 minus taking e power minus omega n into t common, and you are left with 1 plus omega n into t. This is the response for second order system for critically damped case per unit step input, and the output would be like this. The response of critically damped second order system will be having no oscillations. If you do find this video useful, please do like, share and subscribe.